30 scientific facts that sound impossible but are real. 1. Your body is glowing. You just can't see it. You are glowing. Right now. Not metaphorically. Not with joy or inspiration or love. But literally. You are emitting light. Every inch of your skin, every cell, every breath of your body sends out tiny, invisible flickers of light. And no one told you. Because no one can see it. It's called biophoton emission. Ultra-weak light, given off by the chemical reactions, happening inside your body, all the time. Not heat, not infrared, but light. Real photons. Billions of them. Dimming, flickering, dancing, from your cheeks, your chest, your fingertips. Too dim for the human eye. 1,000 times weaker than the faintest light you can see. But there, always there. Scientists once thought it was impossible. A living human, glowing without fire, without radiation, without magic. And yet, in 2009, researchers in Japan used a sensitive photon detecting camera in a completely dark room. 5 volunteers. No lights. No mirrors. Just breath, skin, silence. And the camera saw it. Tiny pulses of light, rising and falling, with the rhythm of the day. You glow more in the afternoon than at night. More from your cheeks than your forehead. Not just heat. This was visible light in wavelengths your eyes can't catch. Your body is not just alive. It is luminous. And it's not new. Other animals do it too. Fish, birds, even plants. Not in the glowing lanternfish, bioluminescent sense, but quiet, invisible shimmerings. Every living thing emits these photons, a result of oxidation, of metabolism, of life. When your body burns oxygen to power its cells, free radicals are formed. Reactive, unstable, crackling bits of chemistry. To keep the balance, your body sends in antioxidants, the cleanup crew. But in the process of that silent battle, a photon is born. One flash, one light. You are not a beacon. You are a constellation. A slow galaxy of flickers, like watching stars from the inside out. It's not magic. It's chemistry. It's physics. It's you. We call it ultra-weak photon emission because it whispers instead of sings. But what it says is astonishing. You are not just a machine. You are a lantern, invisible to the eye, visible to the universe. One spark, then another, then another. Some researchers believe this emission may be linked to how cells communicate. That light might be a language. Cells use to whisper in the dark. A photon from one cell might guide a neighbor, tell it to grow, to rest, to heal. Not a loud comment, a murmur. But in the right pattern, a murmur becomes a message. Your body speaks with light. Not just neurons, not just chemicals, but the purest form of energy. This glow isn't constant. It fluctuates. It pulses with your circadian rhythms. It changes with your health, your age, your stress. Some researchers wonder, could we one day diagnose disease by watching how people glow? Could a camera tell if your cells are in distress before symptoms appear? Before pain speaks, could we catch illness in the flicker of a photon? A body that glows too much or too little might be a body out of balance. And this is where the impossible begins to sound useful. But for now, this is not medicine. This is marvel. Because you were never told that the body is made of light, that even in your stillness, you shine. It's not enough to light a room. but it's enough to fill one with wonder. No mirror will show it. No eye can see it. But the night knows. And the photons don't care if you believe in them. They rise anyway. One spark, then another. And if you could turn the lights off in the universe and look closely, you would see all of us quietly glowing in the dark. 2. You're made of stardust from exploding stars. You are not just human. You are cosmic, and not in a metaphorical, spiritual sense. In the most literal, measurable, elemental way. Your body is made of stars. Not just one. Not a distant one. But many. Countless. Long dead titans of the sky, whose violent ends gave birth to the dust that became you. The calcium in your bones. The iron in your blood. The oxygen in your breath. The carbon in every cell. All of it. Cooked in the heart of ancient stars. Billions of years ago, long before Earth had air, or oceans, or a name, there were stars. Massive, raging furnaces, fusing hydrogen into helium, helium into carbon, carbon into heavier things, oxygen, nitrogen, iron. They did this for eons. Burning, growing, collapsing. And then, they died. But stars don't go quietly. They explode. Violently. Spectacularly. A supernova is not an end. It's a beginning. Because in that explosion, the elements scatter. Thrown across galaxies, like seeds in the wind. Those seeds are the building blocks of planets, of oceans, of skin and teeth and thought. You are a byproduct of violence, too ancient to name. A single spoonful of you contains atoms forged in furnaces 1,000 times hotter than our own sun. And they drifted, for millions of years, floating through dark space, silent, lonely, until they found a home. In a quiet corner of a quiet galaxy, those atoms gathered, spun into a star, a solar system, a planet, and then into breath and bone and heartbeat. You don't just come from Earth. You come from everything before it. The iron in your blood is the same iron that forms the core of this planet. The gold in a wedding ring was formed in a stellar collision, so intense, space itself rang like a bell. And the carbon in your cells, the foundation of all life, was born in the quiet death of a giant. Every time you breathe, you inhale stardust. Exhale stardust. Build yourself out of it. We are not separate from the universe. We are the universe, briefly looking inward. Carl Sagan said, "We are a way for the cosmos to know itself." He wasn't being poetic. He was being accurate. You are evidence that the stars once lived, and now they live again. In your fingers, in your eyes, in the thoughts you never say aloud. The next time you see the night sky, know that you are not beneath it. You are not looking up at something distant. You are seeing your relatives, your roots, your origin story. Light travels from those stars for tens of thousands of years just to be noticed by your eyes. And your eyes, they're made of the very same atoms as the light they capture. The observer and the observed, both made of the same fire. And it gets stranger still. Some of the atoms in you have been part of other bodies before. Not just stars, but other people. Every breath you take contains molecules once inhaled by ancient kings, by dinosaurs, by lovers long gone. You are a remix of everything. And the process continues. Even now, the sun is fusing atoms into helium, sending light across space to warm your skin. And one day, it too will die. Not violently, but with a long sigh. And it will scatter its elements into space once more. And those will become something else. A moon, a plant, a child. You are not static. You are stardust in motion. Everything that feels solid, your hands, your voice, the room around you, is made from particles that once floated free in the silent dark. And someday, they will float again. Nothing is wasted. Nothing is lost. Not even you. You are not here by accident. You are the product of billions of impossible coincidences. And yet, here you are. Atoms rearranged to tell stories, to sleep, to wonder how anything so impossible could ever be real. 3. Time moves slower when you're in the basement. It sounds absurd, but time is not constant. It flows differently, depending on where you stand. Right now, if you're lying on a bed on the second floor of a building, and someone else is downstairs, resting in the basement, you are aging faster than they are. Just slightly. So slightly, you'd never notice. Not in a billion lifetimes. But it's happening. Time is running faster for you. Because you're higher up. Farther from the Earth's center. Farther from gravity's grip. You are stretching time just by sleeping one floor above. This is not science fiction. This is Einstein. Relativity. Gravity doesn't just hold your feet to the ground. It bends time. Warps it. The stronger the gravity, the slower the clock. And Earth, our spinning home, is a clockmaker in disguise. The closer you are to its center, the deeper you sink into its well. And time slows down. Just enough to make physicists gasp. They've measured this. With atomic clocks so precise, they lose only 1 second every few billion years. Put one clock on the ground floor and another on a shelf just 1 meter higher. Wait. Compare. And the higher clock ticks faster every time. A child on their father's shoulders ages ever so slightly quicker than the man beneath them. A mountain climber moves through time faster than a sea diver. Tiny, invisible, inescapable. Even astronauts in orbit feel the push and pull of this paradox. Far from Earth's gravity, they float forward in time, just a little bit faster. But they also move incredibly fast, and speed, too, slows time down. So one effect cancels the other, and the universe keeps its secrets. This is the world relativity built. A world where time is not the same everywhere. Not even inside your home. Stand up. You're now aging faster than when you sat down. Tilt your head back. Congratulations. Your forehead is older than your chin. It's ridiculous. And it's real. The GPS on your phone relies on satellites circling high above the Earth. Up there, far from gravity, time runs faster. And without correction, your map would be off by miles every day. So your phone, quietly and constantly, adjusts for relativity, compensates for the way time slips and stutters as it climbs into the sky. Also, you can find the coffee shop. You don't feel it. You don't notice it. But you live inside a planet that bends the very flow of time. We used to think that time was a river, always flowing forward, always the same. But that's a lie. Our bodies tell us, because we crave certainty. Time is more like a fabric, soft, elastic, and deeply influenced by mass and motion. Einstein saw it in the math. He imagined clocks ticking on trains and satellites and hillsides, and he saw what no one else could, that the universe isn't fair, that where you are changes when you are. And now we know. You don't have to move fast. You don't have to be near a black hole. You just have to go downstairs. That's all it takes to slow the clock. Not enough to change your life, but enough to change your story. You are not living in universal time. You are living in your time. A thread stitched uniquely for you. And so is everyone else. Two twins, one who lives in the basement and one in the attic, will not live the same number of seconds. Not exactly. Not ever. And though the difference is so small that it melts into the background noise, it is still there. Proof that the world is stranger than it looks. Because even when you're still, even when you're asleep, the fabric of reality is tilting beneath you. Time slips, folds, stretches, and you, a quiet traveler between floors, are pulled along for the ride. Part 4. There are more microbes in you than human cells. You are not alone. Not even when a room is empty. Not even when your thoughts are silent. You carry multitudes, an invisible empire, a city of strangers living beneath your skin. And here's the truth. You are more them than you. For every one human cell in your body, there are about 1.3 microbial cells. That's trillions of tiny passengers riding along inside you. Bacteria, viruses, fungi, and archaea, ancient organisms older than anything you've ever touched. They live in your mouth, on your skin, in your lungs, and most of all, in your gut. If you could see yourself as you truly are, you'd be a shimmering outline of human cells wrapped around a dense, teeming core of other life. This collection of life inside you has a name, the human microbiome. And it's not a parasite. It's a partnership, an uneasy truce between evolution and necessity. These microbes digest your food. They make vitamins you can't. They help train your immune system, keep bad bacteria in check, and may even shape your moods and thoughts. They whisper chemical signals that can calm you, or stir you, or nudge your brain towards sadness, or stillness, or sleep. You are not just a mind in a body. You are a host to an ancient colony you didn't choose, but can't survive without. And you've been like this from the beginning. At birth, you were mostly sterile. But within seconds, as you passed through your mother's body, as hands touched your skin, as air filled your lungs, the world entered you. And it never left. Within weeks, your gut became a forest, a jungle, a writhing world of microbial life. By the time you were a toddler, your microbiome was more or less established. A fingerprint of all the places you'd been, all the people who held you, all the food you tasted. Your microbial profile is unique. No one has the same mix, not even identical twins. Your gut is like a snowflake of bacteria, alive and always changing, and they respond to everything, to stress, to diet, to antibiotics, to sleep. Feed them fiber, they flourish. Starve them, they adapt. Take a pill. Some die, others rise. And in this constant churn, something miraculous happens. Out of the chaos comes balance, homeostasis. You, these microbes, are small, tiny, but their genes outnumber yours by a lot. Your human genome contains about 20,000 genes, but your microbiome, it has over 2 million. That means most of the genetic material in your body isn't human. It belongs to your microbial passengers. Your gut bacteria have more instructions, more biochemical tools, than you do. And together, you form what some scientists call a superorganism, a fusion, a cooperative, a walking negotiation between human and microbe. And sometimes, the balance breaks. Diseases like Crohn's, IBS, even depression and obesity have been linked to disruptions in the microbiome, a shift in the population, an invasion, a silence. Your health depends not just on you, but on them. And still, you rarely think about them. You can't see them, can't hear them, can't thank them. But they're there. Every inch of your colon, lined with trillions of whispering cells, feeding, fighting, cooperating, evolving. And if you could shrink down, way down, to the size of a microbe, you would see a bustling city, stretching from your throat to your gut. Rivers of nutrients, colonies at war, alliances made in mucus and bile, a universe within a universe, inside you. And maybe, if you were small enough, you'd look around and wonder, who's really in charge? 5. You share 60% of your DNA with a banana. It's not the kind of fact you expect to hear when biting into a fruit, but it's true. Peel back the yellow skin of a banana, and somewhere, deep inside, you will find echoes of yourself. Not in the shape, not in the taste, but in the code. Because when scientists sequenced the banana genome, and then compared it to your own, they found something quietly astounding. You and a banana share about 60% of the same DNA. And that number is not a mistake. It's a monument to your past. Because life, despite all its wild variation, reuses its tools over and over, across kingdoms, across continents, across time. DNA is the software of life, a 4-letter code written in combinations that stretch across billions of years. A equals adenine, T equals thymine, C equals cytosine, G equals guanine. That's it. Just 4 letters. Endlessly shuffled, copied, and mutated. From amoebas, to oak trees, to dolphins, to you. And somewhere along the winding staircase of your double helix lie instructions that bananas also carry. Genes for cell division, for metabolism, for repairing DNA damage, for producing enzymes, for managing potassium, because life, for all its complexity, is conservative. It doesn't reinvent the wheel, if the wheel still works. So it carries these sequences forward, across the evolutionary tree, tweaking here, duplicating there, but never truly starting over. That's why you don't just share 60% of your DNA with bananas. You share 85% with a mouse, 98.8% with a chimpanzee, and even 40% with a fruit fly. And yes, even a jellyfish carries some of the same genetic instructions as you do. Because once upon a time, long before mammals, long before trees, there was a single-celled ancestor drifting through ancient oceans. And it carried a spark, a piece of the code that would someday stretch into everything. That ancient cell didn't look like much. It didn't feel, or think, or dream. But it split, and grew, and changed, and in doing so, left a legacy, written in letters too small to see. You are part of that story. So is the banana. You diverged. Your paths forked. Billions of years ago. But your blueprints, they still whisper to each other. Not in words, but in base pairs. Shared molecular tools for the business of staying alive. When you eat a banana, you're not just consuming fruit. You're touching something that evolved alongside you. a fellow traveler, on the long road from slime to symphony. And it gets stranger still, because some scientists believe that more than 8% of your human DNA doesn't come from ancient ancestors at all. It comes from viruses, genetic hitchhikers that invaded your lineage long ago and never left. Viral DNA that snuck into eggs and sperm and became part of the human blueprint. So now, inside your cells, pieces of ancient viruses sit quietly, watching, occasionally activating, sometimes helping, sometimes harming. You are not just human. You are a library of everything that's ever infected, everything you've ever been. And still, you function. You thrive. Despite all the strange pieces stitched into your genome, you walk and speak and dream of being understood. All because 4 letters kept copying themselves. And once in a while, those copies got it wrong. Just enough to create a new protein, a new ability, a new species. The nanas can't write poetry. They don't fall in love. But inside their cells is a quiet song you would recognize. The same biological chorus playing in your gut, in your bones, in your breath. So the next time someone calls you a fruit, thank them. Because fruit and human are cousins in disguise. You're not of nature. You are nature, with just enough code to know it. 6. Your stomach lining dissolves and regrows every few days. There's a war happening inside you, right now, and it's being fought in silence. Not between you and something else, but between you and yourself. Because your stomach is filled with acid. Real acid. Powerful enough to dissolve metal. Hydrochloric acid. The kind you wouldn't dare splash on your skin. The kind used in laboratories to strip paint from surfaces, to break down stone. And yet, your body keeps it inside, like a dragon keeping its fire. How? How do you not digest yourself? The answer is simple. You do. Every few days, your stomach lining destroys itself, melts, breaks down under the very acid it produces, and then it rebuilds, layer by layer, cell by cell, a complete replacement, like clockwork, quiet, unseen. You are digesting yourself, constantly, and surviving. Because evolution, in all its brutal brilliance, found a way to make the human body a thing that can rebuild itself, even as it's being eaten from within. Your stomach cells live a fast life. They are born, they work, and they die within 2 to 4 days. Their job is suicidal, to produce mucus that protects the inner walls of your stomach, to create a barrier between your own flesh and the acid you summon to eat. But it's a delicate game. One misstep, one failure, and the acid wins. Ulcers form, pain flares, and the body must send more cells to patch the breach. It is biological warfare, and the battleground is your belly. You feel hunger, but rarely imagine the chemistry behind it. That sensation, that grumble, that pull. It's driven by hormones and nerve signals, yes, but also by destruction. Because the longer you go without food, the more acid your stomach produces. Waiting, simmering, preparing for digestion, even if there's nothing to digest. And so, when the food finally comes, it's not just being broken down. It's being saved from the fire within. That's what your mucus lining does. It protects you from yourself, but only for a little while. Because the lining breaks down quickly. It can't last. So your body replaces it rapidly, continuously. It's one of the fastest regenerating tissues in your body. Only your intestines and skin renew themselves faster. And what drives this endless cycle? Cell division. Stem cells hidden deep in your gastric glands, churning out replacements with factory-like efficiency. Like building a new shield, even as the old one crumbles. And while this might seem like a strange quirk, just another oddity of biology, it's something deeper. It's resilience. It's the body's quiet promise that even in the harshest environments, even under internal attack, you are still rebuilding, still renewing, still standing. There are animals that produce stomach acid even stronger than yours. Crocodiles, vultures, they can digest bones. But you've developed a balance. Strong enough to break food down. Gentle enough to survive your own fury. And we forget this, because pain reminds us of failure, of ulcers, or nausea, or reflux. But what about the miracles that go unnoticed? The lining that returns before you ever miss it. The army of cells that dissolve quietly so that you don't. There are scientists who believe this regeneration process may hold secrets for cancer treatment, for tissue repair, for anti-aging therapies. Because if we could learn how to command the body to regenerate like the stomach, we could change everything. You'd never think of your gut as a laboratory of cellular miracles. But it is. Each bite you eat passes through an ever-changing tunnel of self-destructing defense. And somehow, despite the volatility, you thrive. Your body survives its own weapon. And tomorrow, the battle begins again. No trumpets, no scars, just a stomach with a short memory and a long history of surviving itself. 7. Atoms are 99.999999% empty space. Everything you've ever touched, the bed beneath you, the floor under your feet, the skin on your arms, the breath in your lungs, all of it feels solid. But that's the trick. Because matter isn't what you think it is. It's not dense. It's not firm. It's not full. It's mostly nothing. Every atom in your body, in the stars, in the universe, is 99.999999% empty space. That means, if you took all the atoms in your body and removed the empty space, you would compress down to a speck. Something smaller than a grain of rice. A single cube of sugar could hold all the mass of humanity if only you crushed the space out of atoms. But you don't feel hollow. You don't pass through walls. You don't stink through the chair. So why does anything feel solid at all? Because of force. Because of fields. Because electrons, those tiny, buzzing particles, create an illusion. They repel each other. When your hand touches the table, the atoms in your skin don't actually meet the atoms in the wood. Their electrons resist. They push back. A silent, invisible field, saying, no further. That resistance is what you feel as touch. It's what keeps you from falling through everything. You are a ghost with boundaries, a cloud of particles, held in shape by rules you cannot break. And inside every atom, the strangeness deepens. At the center sits the nucleus, protons and neutrons, dense and massive. But most of the atom is just space. If the nucleus of an atom were the size of a pea, the nearest electron would be several football fields away. Imagine it, a tiny marble, floating at the center of the stadium, and the walls of that stadium are where your electrons spin, and in between, nothing. Just potential. Just distance. Just quiet. This is not philosophy. This is physics. The building blocks of your body are not bricks. They are whispers of energy, suspended in a dance of probability. Because even the electrons aren't fixed. They don't orbit like planets. They swirl in clouds. Their location is not known exactly, only their likelihood. Quantum mechanics tells us that particles behave like waves, that they flicker in and out of being, that their positions are questions until observed. You are made of uncertainty, of maybe, of barely there, and still, you are here, solid enough to hold a book, to kiss someone's cheek, to leave footprints in snow. Your solidity is the result of forces interacting with emptiness. The electromagnetic force holds your electrons near. The strong nuclear force holds your nucleus together. Gravity anchors it all to the Earth's slow pull. But the space remains. The silence inside the atom. The vacancy within everything. And this opens up a thought. If matter is mostly empty, what does it mean to be real? What does it mean to touch, to hurt, to heal, if the atoms doing all this are mostly made of nothing? Maybe it's not the particles that matter. Maybe it's the way they move, the structure they hold, the music they make when they interact. You are not a statue. You are a song, played in fields on a cosmic scale. A tune of energy and repulsion and connection, held together by space and silence. And that might be the most impossible part of all. That out of almost nothing, something emerges. A body, a life, a thought. From the hollow architecture of the atom comes the weight of the world. Hate, you're moving 1.3 million miles per hour through the universe. You feel still right now. Lying in bed, the world quiet, the room unmoving. The walls, the ceiling, the mattress beneath you, all resting in perfect calm. But you're not still. Not even close. You are moving, right now, at a speed so fast that it would shatter your understanding, if you could feel it. Because you are traveling at 1.3 million miles per hour through the cosmos. And yet, you don't notice. You don't hear wind. You don't feel acceleration. Because everything around you, the Earth, the atmosphere, the moon, the entire solar system, is moving with you. Let's break it down. The Earth spins on its axis. That alone means you're moving at roughly 1,000 miles per hour, just by sitting still at the equator. But that's only the beginning. The Earth also orbits the Sun. That's another 67,000 miles per hour. As you hurtle through the solar system, the Sun too is not stationary. It drags us, our entire solar family, around the center of the Milky Way galaxy at a blinding 514,000 miles per hour. And the galaxy itself, it's not idle either. The Milky Way is hurtling toward the Andromeda Galaxy on a collision course, moving at roughly 400,000 miles per hour. Added all together, and the sum is staggering. At this very moment, you are gliding through space at more than 1 million miles per hour. That's not poetry. That's physics. Space is not empty. It is a flowing river of stars and dust and gravity wells. And you're inside it, moving, forever. But the reason you don't feel it is simple. Everything around you is moving at the same speed. Motion is relative. You only feel speed when it changes, when the car brakes, when the elevator starts, when the plane lifts off. But in the great celestial ride, there is no window, no engine hum, no turbulence. Just perfect, invisible inertia. It's easy to imagine the universe as a still painting. Stars frozen, planets pinned like ornaments. But in reality, everything is dancing. Galaxies spiral. Stars orbit. Planets spin. Moons drift. The universe is in motion, and you are a passenger in a vessel that never stops. There is no anchor in space, no center, no edge, just motion upon motion upon motion. And that's part of the beauty. You are not a statue in a garden. You are a leaf carried on a galactic wind. And that movement, though unfelt, is essential. Because without that motion, the cosmos would be cold, still, dead. It is the movement that creates life, the spinning of stars that forges new elements, the orbiting of planets that gives rise to climate, seasons, possibility. Even your own atoms, the particles that make you up, are in motion. Electrons don't sit still. They vibrate, spin, blur. There is no stillness at the smallest scale, and none at the largest. You are not separate from this. You are a moving pattern within a greater pattern. Your body riding a planet, your planet riding a star, your star sailing through the galaxy, your galaxy pulled by unknown forces towards some unseen destination. And you, lying there, feel nothing. But maybe you sense something deeper, a kind of restlessness, a quiet hum, the distant pull of something larger than you can hold. Not a storm, but a tide. Not a race, but a drift. And somewhere in that drift, you are being carried, like everything else, through darkness, through space, through time. 1.3 million miles per hour, without a sound, without a bump, without a clue, and still, you remain whole. A traveler who never knew they were moving at all. 9. Your brain can generate enough electricity to power a light bulb. You don't feel electric. You feel soft, tired, warm. But inside your skull is a storm. Not of wind, not of rain, but of pulses, of sparks, of electrical fire. Because the human brain, that 3-pound cathedral of thought, is not just made of tissue and blood. It's an electrical machine. You run on current. Right now, as you lie still in the dark, your neurons are firing. Billions of them, shooting signals at speeds of up to 268 miles per hour. Faster than a Formula One car. Faster than most people can think. And all of that electrical activity, all those tiny lightning bolts, those cascading charges, those flickers of yes and no, together generate about 20 watts of power. Roughly enough to power a light bulb. Not a metaphor. A literal fact. If your brain's electricity could be harvested with perfect efficiency, you could light a small lamp just by being alive. You are glowing. Not in metaphor. In motion. Each time you think, or remember, or dream, ions rush across cell membranes, setting off voltage changes, microsurges of current, racing down axons. And the brain never stops. Even in sleep, even in deep rest, your mind is never still. Dreaming takes power. So does healing. So does forgetting. There are 86 billion neurons in your head, and each one might connect to tens of thousands of others. You are a walking circuit board, denser than any supercomputer, humming in silence. And the energy it takes, it's staggering. Though your brain is just 2% of your body's weight, it uses about 20% of your body's total energy. That's like lighting a city with a single room. A flicker of thought, a memory returning, a sound interpreted, a word recalled. All of it is electricity. Your thoughts are not weightless. They are charges. They are fire. And they ripple outward. When your neurons fire, they generate tiny magnetic fields. Small, too small to detect without sensitive tools. But real. Your mind isn't just a place. It's a generator. And this electricity isn't wild. It's patterned. Organized into brain waves. Alpha, beta, delta, theta. Each wave has a purpose. Sleep, alertness, meditation, problem solving. And every shift in emotion, every flutter of fear or flash of joy, is accompanied by a subtle change in frequency. You feel it, in ways you don't understand. A headache, a dizzy spell, a sudden sense of clarity. They're often the result of this electric orchestra playing, just a little off-key. And sometimes, in rare moments, the orchestra roars. A seizure, for example, is an electrical storm. A cascade of firing neurons, blinding and unstoppable. But even at its calmest, your brain is alive with charge. And the mystery is this: no wire, no outlet, no battery, just sodium, just potassium, just a careful dance of ions crossing membranes. That's all it takes. And from that comes every poem, every heartbeat, every face you've ever remembered, every word you've ever spoken. It's all powered by a 20-watt current, humming inside your head. So when you lie awake at night, wondering where your thoughts come from, the answer is electric. You are a current, wrapped in bone. And still, the light doesn't flicker. 10. If you removed all the empty space from atoms, humanity would fit inside a sugar cube. Take a breath. Think of everyone you've ever known. Your family. Your friends. The strangers on the street. The billions of souls who live, laugh, sleep, wander, and wonder. Now stretch your mind further. Picture the crowds, cities, nations, the entire human population. 8 billion minds, 8 billion beating hearts. Now imagine compressing all of them. Not their bodies, but their atoms. To remove the space in between. What's left isn't a planet-sized mass. Not a skyscraper. Not even a building. What's left could fit inside a sugar cube. Because atoms are mostly empty. And so are we. Every atom, the building block of your body, is made of a tiny nucleus. Protons and neutrons packed tight. Surrounded by a cloud of electrons. Spinning in what is, effectively, nothing. A single atom is over 99.999999% empty space. If you were to scale the nucleus up to the size of a marble, the electron cloud would stretch hundreds of meters away, and in between, nothing. The solid world you know is built from ghost-like scaffolding, structures held together, not by bricks, but by fields, by probabilities, by repulsions and attractions you cannot see. So what happens if you take all that space away? If you crushed each atom until the electrons were forced into the nucleus, you'd create something terrifying, something real. A hyperdense material called nuclear matter, the stuff of neutron stars. A teaspoon of it would weigh more than Mount Everest. But you wouldn't need a teaspoon. Just a sugar cube's worth would hold the entire mass of every human being alive. That's not science fiction. It's particle physics. It's what's hiding inside us at all times. Not potential energy, but potential density. The universe has always been deceptive. What seems full is mostly space. What seems still is full of motion. What feels solid is a web of forces barely holding form. And this sugar cube thought experiment, it's not just about mass. It's about meaning. Because if we can compress everything we think of as people into something so small, then what defines us? Not volume, not weight, but experience, motion, memory, electricity. And in this invisible scaffolding of mostly nothing, somehow, consciousness blooms. The void between particles creates possibility. The gaps allow for complexity. If atoms were solid spheres, life would be impossible. There would be no chemical bonding, no breathing, no thought. It is the emptiness that allows the dance. So maybe you're not less, because you're mostly nothing. Maybe you're more. Maybe emptiness isn't the absence of matter, but the condition for miracles. And so, within the sugar cube of compressed humanity, there is no laughter, no sorrow, no breath, just mass. But spread us out again. Let the atoms breathy, and we return to what we are, a species of light and structure, of silence and spark, of space and soul. 11. Quantum particles can be in two places at once. There are rules. Rules you were taught without ever being told. That things have to be somewhere. That objects move from place to place. That something cannot be here and there at the same time. But the universe doesn't always care about your rules, especially not at the smallest scale. Welcome to the quantum world, where particles behave like waves, where certainty dissolves, where reality blurs. At the quantum level, particles, tiny things like electrons, photons, don't sit politely in one spot. They exist in probabilities, in smears of maybe, clouds of potential. Until you look, until you ask the question, until you try to know, and only then do they choose. This is called superposition, the eerie truth that a quantum particle can exist in multiple places at once. Not metaphorically, literally. It can go through two slits at the same time, take two paths, spin both ways, be here and there, until you observe it, and it collapses, becomes one thing, chooses a side. But until that moment, it lives in a strange in-between. Not indecision, not confusion, just pure possibility. This is not speculation. This is physics. Tested, measured, verified. In labs all over the world, scientists have watched particles interfere with themselves, as if they walked two roads at once and met their own shadow at the end. It sounds like science fiction, but it's not. It's just deep reality. Stranger than logic, older than thought. Somewhere beneath your world of chairs and clocks, beneath your heartbeat, beneath the molecules that make your skin, the universe is made of maybe, of both slash and, of here slash there, of neither and both. And when you zoom out far enough, those weird little behaviors don't disappear. They shape chemistry, biology, computation, your very existence. Your body is built from particles that used to be in multiple places at once, and maybe still are in ways we can't see. But here's the strangest part. The moment you try to know, the second you measure, pin it down, choose a side, the spell breaks. The wave collapses. The maybe becomes real. The particle chooses. As if the act of knowing creates the fact itself. Some physicists call this the observer effect. Others simply whisper. Reality listens. And so we're left with a universe that hides until we look and becomes what we ask it to be. Particles in two places, spinning two ways, alive in overlapping states, until consciousness, or maybe just curiosity, forces a choice. What else does this mean? We don't know. Not yet. Maybe that your dreams and decisions are shaped by physics you'll never see. Maybe that the world isn't as fixed as you think. Maybe that truth is always stranger the closer you look. Or maybe the universe has always been a question that answers itself when you dare to ask. 12. Your memories are rewritten every time you recall them. You think of your memories as photographs, static, faithful, stored away in mental albums, tucked behind the glass of time. But your mind doesn't work that way. It's not a gallery. It's a rehearsal stage. And your memories, they're actors, always in motion, always adjusting their lines, because every time you remember something, truly bring it to mind, you change it, not metaphorically, not emotionally, biochemically. This is called reconsolidation, a strange, fragile process where memory is not retrieved like a file, but rebuilt. Each time, from scratch, you open the memory, reconstruct it, experience it, and in doing so, you leave fingerprints. A trace of today's emotions, a whisper of what you've learned since, a shadow of the mood you're in as you recall it. The memory becomes part past, part present, part invention. You remember what you remember about remembering, and the cycle continues. That childhood moment you cherish, it has changed because you've thought about it, because you've spoken it aloud, because you've placed it inside a new context each time you told the story. And that trauma you carry, it too evolves. Not always healing, sometimes sharpening, because fear leaves strong impressions in the neural clay. Your brain isn't a hard drive. It's a sculptor with trembling hands. This process is not a flaw. It's survival. Your memories are not meant to be perfect. They're meant to be useful. Your brain prioritizes relevance over accuracy, emotion over chronology, meaning over detail. A tiger seen once is remembered as larger, closer, faster. Not because that's how it was, but because that memory could save your life. And so, our minds edit, they dramatize, they simplify, they blend memories together. Faces shift, voices blur, time collapses. You forget things you swore you'd remember, and remember things that never truly happened. And yet, you believe them. Because memory feels solid. It feels like truth. But it's more like a painting that's still drying. One you keep touching, with each thought, each sigh, each night you lie awake, replaying what was. The act of remembering is not a return. It is a reconstruction. And each time, the bricks are reset, just a little differently. You are the architect of your own past, not the historian, the author. So what then is real? If memories rewrite themselves, what do you trust? Maybe not the details, not the sequence, not even the faces, but the feeling, the ache, the laughter, the cold of that day, the warmth of that hand. Maybe what matters is not that it happened precisely as you remember, but that it mattered. And in a way, maybe every time you recall a memory, you're not just changing the past. You're adding something to it. A trace of who you are now. A brushstroke of growth. A breath of perspective you didn't have before. Your memories are alive, and so are you. 13. Your eyes see the past, not the present. You blink, and the world appears. Effortless. Immediate. obvious. You see a room, a face, a flicker of light, and you believe, without question, that it's happening now. But your brain is always late to the party, because vision is not instant, not direct, not truth. It's reconstruction. You never see the world as it is. You see it as it was. By the time the light bounces off an object, travels to your eyes, gets bent by the cornea, focused by the lens, converted to electrical signals by the retina, and sent racing along the optic nerve to the back of your brain, tens of milliseconds have passed. Tiny, yes, but measurable. And in the realm of the brain, even milliseconds matter. Your eyes are like telescopes, gathering the past. Even the sun you see, that warm circle in the sky, left its surface over 8 minutes ago. You never see it in real time. You see what it looked like minutes before. Stars, you're seeing ancient history. Light that left those burning giants, hundreds, thousands, even millions of years ago. Some of them are gone now. Dead, silent. But their light keeps traveling, keeps reaching us, keeps showing up, as if they're still alive. Ghosts in the sky. But it's not just the stars. Even the people you look at, across a room, on a screen, in a mirror, exist ever so slightly, in the past. Your brain is a master illusionist. To prevent chaos, it buffers everything, smooths it out, reconciles delays between sight, sound, touch, balance. It edits your reality in real time, so you never notice how out of sync your senses actually are. When a lightning bolt strikes, you see it first, and the thunder rolls in late. But when someone claps their hands, you hear it and see it at what feels like the same moment. That's not physics. That's neuroscience. The brain holds the visual signal just long enough to align it with the slower sound. It waits. It patches. It pretends, so that you feel present, whole, here. But you are always living in a slightly delayed world. Your entire perception is a carefully rehearsed playback, an echo of now. Even your decisions, your reactions, your movements, they're all triggered after the fact. By the time you pull your hand from a hot stove, the signal has already raced from your skin, through your spinal cord, and back again, before you even feel pain. You are a time traveler, trapped in the illusion of immediacy. And yet, somehow, it works. You catch balls. You dance to music. You laugh at jokes as if everything happens in perfect synchrony. Because your brain isn't just a camera, it's a simulator. It fills in blanks, predicts, edits, lies, and all of it just to give you the illusion of the now. So when you look around the room, know this. You're not seeing the world as it is. You're seeing its shadow, its afterglow, its echo. A delayed broadcast replayed on the stage of your consciousness. And still, somehow, it feels real. Maybe because you've never known anything else. 14. A spoonful of neutron star would weigh more than Mount Everest. Pick up a spoon. Simple. Ordinary. An everyday thing. You stir your tea. You scoop sugar. It fits in your hand without thought. Now imagine. You filled it with something else. Not soup. Not honey. But matter. From the heart of a dead star. From a neutron star. A spoonful. Just that. No more. And in your hand, you would hold more weight than Mount Everest. Yes, the tallest mountain on Earth. Crushed into a spoonful of collapsed star. So heavy, you couldn't lift it. not even with cranes, not with machines. So dense, it would fall through the crust of the earth, burrow toward the center, unstoppable. So unfathomably massive that the air around it would ripple. The ground beneath it would scream. The laws of matter would bend. Because neutron stars are not like anything you've ever touched. They are the leftovers of massive stars that exploded. Supernova. But the star's core, what's left, doesn't vanish. It collapses. Not into a black hole. Not quite, but close. The atoms themselves are crushed. The electrons and protons, the basic building blocks of matter, are smashed together into neutrons. A city-sized sphere of nothing but neutrons. Imagine the entire mass of the sun packed into something barely 10 miles across. A single teaspoon would weigh around 4 billion tons. That's 4 times the mass of Mount Everest, sitting in your hand. If your hand still existed, but it wouldn't. Because that spoonful would collapse through your body like you weren't even there. Because mass like that creates gravity like that. It would pull the air, the ground, your bones, your breath, all into itself. Even light would curve as it passed near. This isn't just heavy. This is different. The structure of matter reorganized. Atoms flattened. The gaps between particles gone. Neutron stars are so dense that a single cubic centimeter has more mass than all of humanity combined. And yet, they are real. Not myth. Not theory. We've seen them. Through telescopes, we've watched them spin, pulse, send waves through space. Some rotate hundreds of times per second. Blazing lighthouses of collapsed reality. And here you err, stirring your tea, unaware that such things exist, that the universe can pack so much into so little, that the rules you thought were rules are just suggestions at scale. You are made of atoms, air, water, bone. But somewhere out there, in the cold dark, there's a place where none of that means anything, where the weight of a mountain fits in a spoon, and the cosmos doesn't blink. 15. Sharks were older than trees. You swim through time when you look at a shark, not just through water, but through epochs, extinctions, continents that no longer exist. They glide silently, unhurried. A shape so ancient, it predates memory, predates mammals, predates leaves. Yes, sharks are older than trees. Let that sit. Sharks, those creatures with rows of endless teeth, cartilage skeletons, and eyes that stare like time itself, first appeared around 450 million years ago. Trees? About 385 million years. That means when the first tree ever reached toward the sun, sharks had already ruled the seas for 65 million years. Before forests, before flowers, before birdsong and bees, there were sharks. In oceans that covered strange continents, under skies that had never seen dinosaurs, they swam. While Earth was barren, a rocky silence above, sharks patrolled the seas below. They evolved, before insects had wings, before vertebrates crawled onto land, before the ozone layer was finished forming. And they kept going. They survived mass extinctions, ice ages, meteor strikes. When 90% of species vanished, sharks endured, not unchanged. They evolved. They adapted. But the essence remained. That torpedo shape. That sixth sense for electric fields. that silent efficiency of a predator built by time. And as trees grew tall, dropping leaves, spreading roots, learning how to dance with the wind, sharks kept swimming, one in salt, one in soil, both writing the long poem of earth. But make no mistake, the sharks came first. Long before forests made oxygen, before bark and bark beetles, before branches stretched into sky, there were dorsal fins slicing through oceans, older than memory. And maybe that's why, when you look into a shark's eye, there's something unsettling. It doesn't feel like it sees you. It feels like it remembers. As if it's seen creatures like you come and go. As if it swum past civilizations that never left fossils. Because it has. Its ancestors watched the planet bloom. Watched continents drift. Watched mammals rise and fall. It is not the fastest predator, not the smartest, not even the most dangerous. But it is the most patient. It waits, and watches, and survives. And long after the forests fall, after the skyscrapers crumble, after the stories end, the ocean will still whisper, and something with teeth will glide through it, silent and ancient, and absolutely real. 16. There are more stars than grains of sand on Earth. Pick up a handful of sand. Let it fall slowly through your fingers. Each grain, microscopic, countless, timeless. Now imagine every beach, every desert, every dune, every shoreline, from the Sahara to the seafloor. Each square meter, filled with billions of grains. Each wave, polishing them for centuries. And then, dare to imagine more. More than that. More than all of it. Because the stars, those distant fires, scattered across the sky, outnumber them. There are more stars in the universe than grains of sand on Earth. This isn't poetry. It's math. The average beach contains roughly 1 billion grains in a single cubic meter. Multiply that by every beach, every desert, every dust-covered plain, and you reach a number so large you can't truly picture it. Something like 7.5 x 1020 grains of sand. A number with 20 zeros. But the stars surpass even that. The observable universe contains about 2 trillion galaxies, each one with hundreds of billions of stars. That's 2x 1012 galaxies, each holding, say, 2x 1011 stars. Do the math, and you reach something around 4x 1023. More stars than grains of sand. But still, it feels backward, doesn't it? Because we see sand. We touch it. It piles in our shoes. It warms under our feet. And the stars, they feel so far away, so silent, so few. We see maybe a few thousand with the naked eye. But we're peeking, through a keyhole, into a cathedral. You don't see the stars. You see the ones close enough to glow, against the darkness. But beyond that, far beyond, they continue. In clusters, clouds, spirals of light, spinning in void. They burn in silence, at incomprehensible distance. And yet, you are part of that, made of it. Because those stars, those billions upon billions, are not just decorations. They are forges, every atom heavier than helium, carbon, nitrogen, iron, oxygen, was born inside a star, exploded, scattered, recycled. You are made of stellar ash, a walking arrangement of cosmic debris, held together for a brief time, looking back at the source. And when you scoop sand in your palm, you hold a miracle of earth. But when you look up, you glimpse the chaos that made you. Every grain of sand, once belonged to a stone, a mountain, a planet's long erosion. But every star is still burning. Distant, yes, but real. And as you lie still tonight, wondering what it means to exist in a world so vast, remember this. You are not small, because the universe is big. You are rare, because you get to know it, to count its grains, to trace its stars, and to wonder, for a moment, how something so infinite made something like you. Part 17. Black holes aren't holes. They're spheres. You hear the name and imagine a hole. A bottomless pit. A cosmic drain. A tear in space that sucks everything in. Black hole. The words suggest absence, an emptiness, a void. But black holes aren't holes at all. They're spheres. Real, round, physical things. Massive objects with weight, volume, and boundaries. Not flat, not hollow, not missing. Just so dense and so strange that they've fooled our metaphors. If you were to float toward one, slowly, carefully, you wouldn't fall through a flat circle in space. You'd approach a sphere, dark, perfect, smooth. At first glance, you might not even know it was there. Because black holes don't glow. They don't shine. They hide. But the boundary around them, the point of no return, has a name, the event horizon. A perfect sphere wrapped around a singularity. It's not solid. You wouldn't bounce off it. But it marks a limit. A line you cannot cross and come back from. Once light passes that invisible edge, it's gone. Forever. Not because the black hole is a hole, but because it curves space so steeply, so sharply, that even light can't climb out. That's why it appears as a hole. Because light can't escape, and your eyes are slaves to photons. So your mind fills in the blank. It draws a pit, a tunnel. But physics draws a sphere. Perfect. Terrifying. Beautiful. Even time behaves differently near one. The closer you get, the slower time moves, at least from the outside. Hover near a black hole for an hour, and centuries might pass elsewhere. Not because you're dreaming, but because space and time are not what you thought. They are stretchable, twistable, and black holes, they twist the most. Inside, we don't know. No one does, not yet. The laws of physics break down. Our math unravels. Singularity. A word that means, don't look here. A word that says, the story ends. But the shape. That part, we know. Not a void. Not a tunnel. Not a portal to elsewhere. A ball. A dark, dense sphere that bends the universe around it, like a heavy stone in a silk sheet. You can orbit one. You can fall into one. You can even dance along its edge, if you go fast enough. But you cannot call it a hole. That's just the word we made up when our minds couldn't fathom a star that collapsed into itself and kept falling forever. So tonight, as you picture the black hole, the one at the center of our galaxy, or the one that may someday swallow the Earth, long after our sun is dust, don't see a drain. See a sphere. Heavy, quiet, real, and impossibly strange. 18. If you shrunk the sun to a few miles wide, it would become a black hole. The sun feels enormous. And it is. 1,000,000 Earths could fit inside it. It burns 24/7, fusing hydrogen into helium, releasing enough energy to sustain life on a pale blue dot, 93 million miles away. It is gravity. It is light. It is warmth. It is everything. But what if you crushed it? Not turned it off, not dimmed it, not destroyed it, but shrunk it, made it smaller, and smaller, and smaller still, kept all the mass, but took away the space, compressed the sun, until it's no bigger than a small city, maybe 6 miles wide, something you could walk across in an afternoon. What happens then? It becomes a black hole. Not figuratively. Not in theory. Literally. Because the sun, for all its heat and fire, is held together by balance. Outward pressure from fusion, fighting inward pull from gravity. But if the fusion stopped, if the core collapsed, and gravity had no opposition, it would fall inward, implode. And if it fell far enough, if its entire mass were packed tightly enough, it would cross a threshold, the Schwarzschild radius, the tipping point, where space folds in on itself, where escape velocity exceeds the speed of light, where no force, not rockets, not light beams, not prayers, can break free. You wouldn't see an explosion. You wouldn't hear a bang. Just a star, vanishing, replaced by something darker, something heavier, something final. A black hole, born not from magic, but from math. This is the terrifying beauty of gravity. It doesn't need to tear. It doesn't need to rage. It only needs mass and patience. Compressed anything enough. An elephant, a planet, a star, and you'll get the same result. A point from which no light escapes. And the sun. It's no exception. In fact, the only reason it isn't a black hole is because it's too lively, too balanced, too outward. But that won't last forever. In about 5 billion years, the fuel will run dry. The balance will tip. And though the sun will never naturally collapse, far enough to become a black hole, the math remains true. Shrink it small enough, and it would. Because black holes aren't made from mystery. They're made from matter, from the same atoms you're made of, the same light you see by. All it takes is enough gravity in a small enough space, and even the mightiest star will bow. 19. Plants can hear and react to sounds. They don't have ears. They don't have brains. No drums to vibrate. No neurons to fire. And yet, plants can hear. Not in the way you hear a lullaby or a whisper, or the rain tapping on a window, but in the way life listens without knowing. In the way cells respond before language, before meaning. Because science has discovered something strange and oddly beautiful. Plants can detect sound, and more than that, they react to it. In a silent room, a scientist played the sound of a caterpillar chewing near a leaf. No caterpillar. Just the recording. The plant responded. It released chemicals, defensive compounds, just as if it were under attack. It heard the sound of danger, and it prepared. And that's not all. Roots, buried in the dark, have been shown to grow toward the sound of flowing water. Even when there is no moisture nearby, just the hum of movement. They move toward it. Not because they know, but because they sense. And sunflowers. They've been observed synchronizing their movements with one another, communicating in patterns that suggest sensitivity to vibrations in the air. There are even suggestions that music, gentle tones, low frequencies can influence how a plant grows. Faster, fuller, healthier. Of course, this isn't hearing, as we know it. There are no conscious thoughts, no symphonies in their minds. But biology rarely needs consciousness to perform a miracle. What it needs is sensitivity, a way to feel the world without eyes or ears. And plants, quiet as they seem, are constantly listening to wind, to touch, to the vibrations of footsteps, to the low hum of insects, to the microscopic rhythms of life unfolding around them. They pick up changes in air pressure. They feel vibrations in the soil. They know when a storm is coming, not by watching clouds, but by absorbing the tremble in the wind. And when a leaf is touched, some plants shiver, react, close, flee in the only way they can, by folding in. Mimosa pudica, the shy plant. Touch it, and it collapses. Not out of fear, but out of ancient reflex. An answer to the unseen. This is not fantasy. This is not myth. This is modern botany. Acoustic ecology. The frontier where physics meets plants and finds that silence was never really silent. You live among listeners, not just birds and beasts, but stems, leaves, petals, and roots, leaning into the air, sensitive to your passing. You may not think of plants as aware, but they grow toward light. They reach toward water. They defend themselves from predators. And now, we know they respond to sound. They do not speak. They do not sing. But in their own way, they listen. And perhaps tonight, as the wind rushes the trees, outside your window, they're listening to you too. 20. The universe might be a hologram. You're sitting in a room. 4 walls. A ceiling. A floor. You feel your weight. You feel the ticking of time. You feel real. But what if everything around you, everything you see, everything you touch, is a projection? Not an illusion, not a dream, but something far stranger. What if the entire universe is a hologram? It sounds impossible, like something out of science fiction. But some of the sharpest minds in physics are whispering that it might be true. And it starts with black holes. In the 1970s, a scientist named Jacob Bekenstein noticed something strange. The more stuff you throw into a black hole, the more its surface area increases, not its volume. It was as if the black hole was storing information on its surface, not inside. Then Stephen Hawking came along and said black holes emit radiation. They can evaporate. But if they do, where does the information go? Information, you see, isn't just data. It's the building block of reality, the DNA of physics. And physics has a rule. Information can't be destroyed. So where does the information go when a black hole fades away? That puzzle led scientists to a breathtaking idea. What if all the information inside a black hole is actually encoded on its surface? And if that's true for black holes, what if it's true for the entire universe? Think of a hologram, a flat piece of film that contains a 3D image. Tilt it, and you see depth. You see roundness. You see what isn't really there. Now scale that up. What if our 3D universe, everything from galaxies to your hand, is encoded on a 2D surface, somewhere far beyond? What if death is an illusion? What if gravity, mass, and even time emerge from something that's fundamentally flat? This is called the holographic principle. And it's not just poetry. It's mathematics. String theory, quantum mechanics, and general relativity all begin to harmonize when viewed through this lens. It might explain why the universe feels fine-tuned, why quantum entanglement is instant, why gravity behaves like information flow. It's as though the universe isn't the stage. It's a story written on the edge of something else. And what you experience as three-dimensional life is a reading of that edge. Not a simulation, not a glitch, but something deeper. A cosmic mirage built from code and curvature. You are real, but your realness may be encoded somewhere else. Like a shadow cast from a fire you can never see, or a whisper echoing from a wall you'll never touch. So when you close your eyes tonight and feel the pull of the earth, the breath in your chest, the softness of the pillow beneath your head, know that it all might be the echo of a deeper truth, unfolding quietly on a distant edge of everything. 21. The vacuum of space is not empty. Space looks empty, vast, silent, black, a cold nothingness that stretches forever between stars and galaxies. We call it a vacuum, a void, a place where nothing lives, nothing moves, nothing is. But that isn't true, because space is not empty, not truly, not ever. Even in the deepest corner, between the stars, where no light shines, and no atoms drift, something remains. A hum, a flicker, a quantum heartbeat. The vacuum of space is a sea of energy. Invisible, but real. Physicists call it the quantum vacuum. A realm where particles are never truly still. They flicker in and out of existence. Virtual particles. Borrowed energy. Popping into being and vanishing just as fast. Particles and antiparticles, dancing together, existing for a moment, and then canceling out. And yet, their presence can be felt. They shape how atoms behave. They affect the push and pull of forces we once thought were empty-handed. In 1948, two metal plates were placed, very close together, in a vacuum, and they moved, drawn toward each other, by nothing. No air, no heat, no static. Just nothing. And yet, not nothing. It was the pressure of quantum fluctuations, energy buzzing in the vacuum, that nudged the plates together. This is called the Casimir effect. Proof that the void is alive. And there's more. In every cubic centimeter of what we call empty space, there is enough energy to boil oceans. It's hidden, latent, folded deep in the laws of physics. If we could tap into it, harness the vacuum energy, we could power civilizations for eons. But we can't. Not yet. Maybe not ever. Because this energy is woven too finely. It slips through fingers, like a dream. And even stranger, some physicists believe the entire universe was born from that nothing. From a quantum fluctuation in a vacuum, so dense with possibility that space itself tore open. The Big Bang. Perhaps not the start of everything, but the rise of something from a vacuum that was never truly empty. A quantum ripple. A swell in the silence. And then, time, matter. You. So when you gaze into the night sky and see only blackness between the stars, remember, it's not empty. It is the most quietly restless place in the universe. A veil of quantum storms simmering beneath. A perfect silence. 22. Your body replaces itself constantly. You are not who you were. Not yesterday. Not last year. Not 10 years ago. Because your body, quietly, invisibly, is replacing itself. All the time. Without permission. Without applause. The skin you touch, the bones that carry you, the blood that flows, they are all in motion, even when you feel still. Every second, millions of cells in your body die, and every second, millions more are born. Like a forest shedding leaves while growing new ones. You are a walking, self-renewing miracle. Your skin, that soft armor between you and the world, sheds and renews itself every few weeks. Your stomach lining, burned by acid, regrows in days. Your liver, that quiet chemist in your belly, can regrow, even after losing a piece. Your red blood cells last about 4 months. Then they are replaced, constantly, faithfully. Even your bones, those solid, silent pillars, aren't as permanent as they seem. The skeleton beneath you is a living tissue. It is broken down and rebuilt, cell by cell, every 10 years or so. And the heart, its cells linger longer, some for a lifetime. But even here, change flows quietly beneath the rhythm. You are not a statue. You are a river in the shape of a person. A biological symphony of turnover and renewal. But here's the strange part. Even as the matter changes, the pattern remains. The cells may die, but the instructions survive. The blueprint continues. You carry on. Which means the you that exists isn't in the atoms. It's in the structure, the pattern, the ongoing choreography of rebuilding. You are like a flame, burning steadily, though the molecules within it are constantly changing. So when you think of aging, or memory, or identity, pause. Because the body you live in has been replaced many times over. You are both new and old, fresh and familiar. A ship with new planks, but the same name. A question with the same answer, but different letters. So tonight, as you lie still and feel the weight of your body sink into the bed, know that you are a quiet miracle of motion within stillness, and that by tomorrow morning, you'll already be a little more new. 23. Ants don't have lungs. Beneath your feet, beneath the soil, beneath the floorboards of the quietest night, a world stirs. Small lives. Tiny bodies. Marching in order. Building in silence. Fighting, farming, foraging. Ants. Millions of them. Everywhere. We often don't see them, yet they surround us. In jungles, in deserts, in cities. They carry leaves 10 times their weight. Build colonies the size of office buildings. Wage wars with other ant nations. Rescue their injured. Divide labor. Farm aphids. Tend to fungus gardens. They are builders. Warriors. Architects. But they are not, in the way we understand it, brothers. Because ants don't have lungs. No inhale. No exhale. No ribcage expanding. No air filling a chest. And yet, they are alive. Buzzing with purpose. Teeming with motion. So how do they breathe? In their own alien, ancient way. Instead of lungs, ants rely on a network of tiny tubes woven through their bodies. Spiracles. Microscopic holes in their exoskeleton line the sides of their torso. And through these holes, air enters. It doesn't get pumped. There is no beating lung, no breath drawn in. Oxygen seeps, diffuses, like a whisper passing through paper. It travels down branching tubes, called tracheae, reaching every cell, without blood to carry it. There's no hemoglobin. No red cells rushing with oxygen cargo. Instead, they let physics do the work. Simple diffusion. A passive, elegant flow from high concentration to low. It's efficient, silent, ancient, and it only works because ants are small. If they were larger, they'd suffocate, which is why they are bound to this size, this scale, this world just below ours. A civilization, just out of sight, buzzing without lungs, without breath. And it works so well, in fact, that ants have been doing it for over 140 million years, long before humans, long before lungs evolved in mammals, long before we stood upright and drew our first breath of morning air. They thrive without inhaling, survive without lungs. Proof that life finds a way, even in the absence of the obvious. So the next time you see a trail of ants curving across a sidewalk or vanishing into a crack in the wall, pause. Remember that inside each of those tiny bodies is a miracle, a system so foreign, yet so familiar. A reminder that there are many ways to be alive, and not all of them require lungs. 24. Space-time can ripple like a pond. Imagine a pond. Still, silent, glass smooth. Then, a stone drops, and ripples bloom outward. A quiet tremble across the surface, carrying the memory of something that disturbed the calm. Now imagine that pond is space-time, and the stone is a collision between black holes. Not metaphor, not poetry, but physics. Because space-time, the very fabric of reality, is not rigid. It bends, it stretches, and yes, it ripples. In 1916, Albert Einstein imagined this. He said gravity wasn't a force, pulling planets and stars together. It was geometry. Mass bends space-time, and other masses follow that curve. Like marbles rolling on a stretched sheet, like moons caught in the soft dip of Earth's invisible gravity. But he didn't stop there. He wondered, what happens when massive objects move suddenly, violently? When stars explode, when black holes crash, could they shake space-time itself? Could they send out waves, not in air, not in water, but in the fabric of the cosmos? He called them gravitational waves. And for 100 years, they remained only theory. Invisible. Undetectable. Ghosts in the equations. Until 2015. In a quiet observatory called LIGO, a pair of lasers waited patiently. Then one day, a shiver. Not in the building. Not in the air. A distortion in the length of space. Smaller than a proton. A ripple. From 1.3 billion light-years away. Two black holes had collided, and the universe rang. It was the faintest echo, but it confirmed what Einstein saw a century before. Space-time is not a silent backdrop. It's alive with motion. Every massive movement, every cosmic event, sends out these gravitational waves. Ripples that carry memory, shape, and violence through the deep black of space. They move at the speed of light, and they never stop, never fade. The universe remembers. And here's the part that feels like fiction. When these ripples pass through you, your body stretches, then compresses, then returns to normal. You don't feel it. It's unimaginably tiny. But it happens. You are being ever so slightly reshaped by the aftershocks of ancient collisions. Like a violin string, vibrating to a sound you cannot hear. So now, when you look up at the stars, remember, you're floating in a medium you can't see. A pond without edges. A stage that moves. And in that stage, great ripples travel, carrying stories of things so distant So massive, so powerful. They have no words, only waves. 25. You are more microbe than human. You look in the mirror and see a person. Skin, hair, eyes that blink back. A familiar face. But what if that reflection isn't entirely you? What if the thing you call you is actually a crowded city, a bustling, humming, teeming metropolis of life you cannot see? Because your body, this body, isn't just human, not even mostly. Right now, you are home to trillions of microorganisms, bacteria, viruses, fungi, archaea, living in your mouth, on your skin, inside your gut, in your eyelashes, in your lungs, everywhere. They outnumber your human cells. By some estimates, for every human cell in your body, there is at least one microbial cell. You are, quite literally, more microbe than man. And no, this isn't an infection. This isn't invasion. This is your microbiome, your second genome, your unseen self. Without them, you cannot survive. They digest your food. They train your immune system. They produce vitamins. They influence your mood, your memory, your brain. They whisper in chemicals, signal in sense, and shape the very chemistry that makes you feel like you. Inside your intestines, there are more microbial genes than stars in your galaxy, more diversity than all the animals on Earth. And here's something stranger. Your microbiome is unique, as personal as a fingerprint, shaped by your birth, your diet, your kisses, your pets, your grief. No two people have the same microbial self. You shed these microbes everywhere you go, on doorknobs, on loved ones, on the pillow where your head rests at night. You leave behind a signature, an invisible version of you that lingers. And yet, they are not you. They're not made of your DNA. They're foreign, alien. And still, without them, your body malfunctions. Your systems falter. Your brain dims. They're your passengers, your symbionts, your invisible engineers. You are a composite being, a walking ecosystem, a galaxy of cells, all working in harmony to keep you alive. So when you think of yourself, think bigger, think smaller, think stranger. You are not just one organism. You are a we, a collective, a constantly shifting colony of life. And every breath, every bite, every heartbeat echoes with the help of a trillion tiny others living within and upon you. 26. Time moves faster in the mountains. Time feels simple. 1 second, then the next. Always ticking forward, equal for all, unchanging. But that's only how it feels, not how it works. Because time, real time, Einstein's time, can stretch, can bend, can change. And it does, every day, all around you. You don't notice, but physics does. Time moves slower when you're closer to gravity. The deeper you are in a gravitational field, the more space is curved, and the more time slows down. This isn't science fiction. It's general relativity. And it means this. If you stand on a mountain and your friend stands in a valley, you will age faster, by nanoseconds. Tiny, unnoticeable moments, but real ones. The higher you go, even just a few meters, the faster your clock ticks. Not metaphorically. Literally. Astronauts, orbiting above the Earth, age faster than those on the ground. Their seconds stretch ever so slightly longer. Their days pass just a little more quickly. Even the GPS satellites that guide your phone must account for this distortion. They're high above Earth, where gravity is weaker, so their internal clocks run faster than ours. Without correcting for this, your location on Earth would be off by miles. And so, we adjust. We bend time back into sync. But still, the truth remains. There is no single time for everyone. Time is a local experience, shaped by where you are, how fast you're moving, how deep you are in the well of gravity. So when you hike up a hill or look down from an airplane window, you are stepping into a different rhythm. Not enough to feel, but enough to measure. Enough to remind you that time is not fixed, not universal, not absolute. It flows like a river, sometimes fast, sometimes slow, depending on the bends and slopes of the cosmos. And maybe, just maybe, you're older now than someone else who stayed below. Just by a whisper, just by a sliver, but still older. 27. Your bones are stronger than steel. You don't think about them. Not unless they break, or ache, or show up as shadows on an X-ray screen. But every day, they carry you, quietly, faithfully. Your bones, the scaffolding of you, the part beneath the part you show. They seem brittle, white, dry as chalk, but inside, they are alive, dynamic, porous, smart, and stronger than they look. Much stronger. In fact, for their size and weight, your bones are stronger than steel. That's not exaggeration. It's physics. A cubic inch of bone can bear more weight than a cubic inch of steel. It's not just hardness. It's structure. Steel is solid. Bone is a miracle of engineering. It's built with a honeycomb matrix, a lattice of calcium phosphate, woven through with collagen, a blend of hard and soft, brittle and bendable. This design, part mineral, part protein, gives it resilience. When pressure comes, bone can flex, absorb shock, disperse force. It doesn't just crack. It resists. Engineers have studied it to build better bridges, better skyscrapers, better armor. Nature, once again, was first, and bones don't just sit there. They respond to your life. They thicken with use. They hollow with neglect. They grow stronger under stress, weaker in stillness. They are listening to how you move, to how you rest, to what you need. Every step you take is a conversation with your skeleton, and it answers by adapting, reinforcing, changing. Even now, while you lie still, your bones are at work, old cells being eaten, new ones being laid down. A slow, constant renewal, a quiet remodeling of the house you live in. And when something breaks, a fracture, a snap, they don't panic. They heal. No command required. No conscious effort. Just biology, knitting calcium and collagen, like a weaver with invisible hands. So when you think of strength, don't just think of muscle. Think of the framework, the deep structure, the part of you that holds everything else up. It may not gleam. It may not move. But inside your body, just beneath the surface, is a substance, stronger than steel and smarter than stone, and it's yours. 28. The coldest place in the universe is on Earth. Space is cold. Colder than your breath in winter. Colder than the shadowed craters of the moon. Colder than the lonely void between distant galaxies. In the vacuum of space, where stars are sparse, and energy is rare, temperatures drop to unimaginable lows, near absolute zero, the point where atoms almost stop moving. You might think, surely, the coldest place in the universe must be out there, in some far corner of the cosmos, where light never touches. But no, it's here, on Earth, inside a lab, beneath the steady hum of carefully calibrated machines. Scientists have built a kind of artificial winter that no corner of space can compete with. In 1995, a team of physicists did the impossible. They cooled a collection of rubidium atoms to just a whisper above absolute zero, a mere 170 nanokelvins. That's 0.00000017 degrees above the coldest temperature the universe allows. At that moment, in that tiny cloud of atoms, a new state of matter appeared, a Bose-Einstein condensate, where particles lose their individual identity and behave as one, where quantum effects, usually trapped in the invisible world, become large enough to see. It was colder than anywhere else in the cosmos. Even the Boomerang Nebula, the coldest natural place ever found, still sits at 1 Kelvin. Earth beat it by orders of magnitude. And today, in laboratories across the world, scientists routinely create these pockets of perfect cold, using lasers, using magnetic traps, using methods so precise they seem like science fiction. Why? Because cold slows everything down. And when things slow, they reveal secrets. The subtle hum of quantum behavior. The way matter changes when time crawls. Cold is a microscope for physics. And the closer we get to absolute zero, the more clearly we hear the quiet music of the universe. So while the stars burn bright, and black holes swirl in silence, beneath the surface of our warm planet, in the hands of careful humans, we've made something colder than anything nature has ever seen. The coldest place in the universe is not a frozen moon or a dying nebula. It's a breath trapped in a bottle, a near stillness in a vacuum chamber, a whisper of near nothingness, right here on Earth. 29. The speed of light isn't always constant. We're told it's the universal speed limit. Nothing goes faster. Nothing can. The speed of light, 299,792,458 meters per second. Precise. Immutable. Sacred, almost. But what if even that isn't so certain? Because under the right conditions, light, the fastest thing in the universe, can slow down. And in some cases, it can stop. In 1999, scientists passed a beam of light through an ultra-cold cloud of atoms, a state of matter called a Bose-Einstein condensate. And what happened defied intuition. The light slowed to just 38 miles per hour. A beam, usually fast enough to circle the globe 7 times in 1 second, was crawling like a car on a suburban street. Then they did it again, and stopped it completely. Not metaphorically. Literally. The light halted. Its information stored, then released again. Like freezing a ripple in time, and letting it continue, on cue. And that's not the only twist. In the early universe, some theories suggest the speed of light may have been different. Faster. Before physics settled. Before the constants were constant. Because what we call laws might have once been suggestions, evolving rules in a newborn cosmos, still figuring itself out. So now, The very idea of a speed limit is no longer simple. It's conditional, contextual, a truth that depends on where and when you are. So the next time you hear that light is the fastest thing there is, know that even it can be slowed, trapped, and changed, not by force, but by the subtle touch of temperature, matter, and the strange fabric of space itself. 30. There's a planet made of diamond. Far beyond our skies, past the pull of our sun, beyond Mars, Jupiter, Saturn. Farther still, there are worlds we'll never walk. Worlds born in silence. Orbiting stars with no names on our maps. But one of them, 40 light years from here, isn't just another rock or another gas giant. This one may be made of diamond. A planet called 55 Cancri, twice as wide as Earth, 8 times as heavy, tucked so close to its star that a year lasts only 18 hours. There's no cool night, no water, no clouds, only blistering heat, surface temperatures that can melt iron. But it's what lies beneath the surface that has scientists stunned. Because this planet is rich in carbon, and carbon, when squeezed hard enough, under pressure and time, does what carbon always does. It becomes diamond, not flakes, not scattered stones, but entire layers, mountains of diamond, valleys of diamond, possibly a crust of crystal. Imagine standing on that surface, a hell of heat and glitter, where the air would boil, but the ground would shine. Not just a jewel, in the poetic sense, but a literal one. A gem, planet-sized, and it's not alone. There may be others. Whole worlds formed from the ashes of carbon-rich stars, compressed into sparkling spheres that shimmer in eternal darkness. A reminder that the cosmos doesn't follow our rules. It doesn't ask what's possible. It just is. A universe where rain can be molten glass, where winds rage at supersonic speeds, where some planets are covered in ice that burns and others shine like diamonds no eye will ever see. And somewhere out there, spinning quietly in its 18-hour year, is a world made not for life, not for love, not for stories, but for pressure, for beauty born in silence. A planet that glitters but does not glow. A planet you could never walk on, but still you can imagine. You've wandered through atoms and galaxies, through ancient oceans and frozen stars. You've touched light that slows and time that bends. You've seen that your body isn't what it seems. More microbe than human, more empty than solid, more stardust than soil. And maybe now, just a little, the world feels stranger, not scarier, not darker, just wider. Because the universe is not a place of answers. It's a place of mystery. Endless, patient mystery. Layered deeper than our language, moving quieter than our thoughts. You've learned that plants can listen. That black holes aren't holes. That diamonds can be planets, and your breath once passed through the lungs of forgotten kings. And still, there's more. Always more. For every fact we know, there are 1,000 we haven't asked yet. And here you are, a flicker of awareness, in a galaxy that spins too fast to feel. Built from particles, older than the sun, held together by forces you can't touch, and somehow, you are still awake, still breathing, still wondering. That may be the most impossible fact of all. So tonight, as your body grows quiet and your thoughts stretch thin, Let the strangeness settle around you like a blanket. Let it soothe. Let it soften. Let it whisper that it's okay not to understand. You are part of the impossible. You are the question the universe keeps asking. And somewhere, in the cold between stars, or the heat of your own chest, the answer might be dreaming, too. Sleep well, traveler of mysteries. The cosmos will still be here in the morning.